1, 2, 3, 4, and 5, where there is an obvious pattern to the number of terms, and in this case, the first 5 whole numbers. More generally, if we take a sequence of numbers, u sub 1, u sub 2, u sub 3, to the u sub n, then we can write the sum of these numbers as u sub 1 plus u sub 2, u sub 3, so on to the u sub n. Here, the sigma is the Greek capital letter sigma, corresponding to the letter S, and refers to the initial letter of the word sum.
Summation denotes the sum of all values and is represented by the Greek capital letter sigma. Summation notation. Definition. Let x sub 1, x sub 2 to x sub n represent observed values of a quantitative variable x. The sum of these n values is represented by summation x sub I as I goes from 1 to n equals to x sub 1 plus x sub 2 plus x sub 3 to x sub n. Parts of summation notation. A Greek letter sigma is the summation symbol or simply summation notation. I means index of summation, 1 means lower limit, n means upper limit, and x sub I means sum.
Here are the 3 summation properties. First is the property 1. Summation of a constant of c is a constant, then it is read as summation of x sub I as I goes from 1 to n. Next is the property 2. Property 2 is the easiest among the 3 properties. If c is a constant, then summation of c as I goes from 1 to n. Here you need to multiply the upper limit to the constant, and that is the answer. Next is the property 3. Property 3 states that summation is distributed over addition. So it is read as summation of x sub I plus y sub I as I goes from 1 to n. It is distributed by means of summation of x sub I as I goes from 1 to n plus summation of x sub y as I goes from 1 to n. Let me give you an example in property number 1. Let's say that the example is summation of x sub I as I goes from 1 to 3. As mentioned earlier, the 3 serves as the upper limit and the I is the lower limit. So the value of I will be the starting point and the value of the upper limit will be the end point. So it would be x sub 1 plus x sub 2 plus x sub 3. Another example, example number 2. Let's say the given is summation of x sub I, y sub I, as I goes from 1 to 4. It would be expanded as the same procedure did in the number 1. So x sub 1, y sub 1 plus x sub 2, y sub 2 plus x sub 3, y sub 3 plus x sub 4, y sub 4. If there are given values of x and y, you need to substitute it. So it would be, let's say that the value of x sub 1 is 2, the value of x sub 2 is 3, and the value of x sub 3 is 4. X sub 4 equals 6. Y sub 1 equals 3, y sub 2 will be 4, y sub 3 equals negative 2, y sub 4 equals negative 3. So since it is read as x sub I, y sub I, it would be multiplied. So 2 times 3 equals 6, plus 3 times 4, 12, plus 3 times negative 2, negative 6, and the 6 times 3, 18. So since 6 plus 12 equals to 18, and this is negative 6 plus 18, so 18 plus 18 equals 36 minus 6, so the answer is 30. Property 2. If c is a constant, then summation of c as I goes from 1 to n. The thing to remember in property number 2 is multiply the upper limit to the constant, so it will be the answer. Okay, let me give you an example. Example number 1. Summation of 5 as I goes from 1 to 4. Here, you can disregard what is written in the lower limit, which is 1. So you need to multiply the upper to the constant. Upper limit multiplied to the constant, the value of the upper limit is 4 and the constant is 5. multiply the upper limit to the constant. So 5 times 2/3 equals 10/3. So that is the final answer.
Property number 3, the summation is distributed over addition. In this summation, you can read this as quantity x sub I plus y sub I as I goes from 1 to n. In this quantity, you can separate or expand this equation or summation, and it will be x sub I as I goes from 1 to n plus y sub I as I goes from 1 to n. The example number 1 is another example we can encounter in sigma notation. X as a summation of xi cubed as I goes from 1 to 3, you can expand this summation or sigma notation in as x sub 1 cubed plus x sub 2 cubed plus x sub 3 cubed. Since there are values, given values, x sub 1 is equals to negative 2, x sub 2 is equals to 3, x sub 3 is equals to negative 1, you can use the substitution method in the expanded notation. Therefore, x sub 1 will be negative 2 cubed, x sub 2 will be 3 cubed, plus x sub 3 negative 1 will be negative 1 cubed. Simplify those terms. Negative 8 plus 27 minus 1, negative 8 plus 26 is equals to 18. 18 is your final answer.
Example number 2 is under property. So the given is summation of 2x sub I squared plus y sub I as I goes from 1 to 3. First, you need to extract 2. Then expand by starting in the lower limit and goes to the upper limit. So x sub 1 squared plus x sub 2 squared plus x sub 3 squared. Then let's go to the y sub I. So it would be y sub 1 plus y sub 2 plus y sub 3. So we have given values x sub 1 equals negative 2, x sub 2 equals 3, x sub 3 equals negative 1, y sub 1 equals 2, y sub 2 equals negative 3, and y sub 3 is 4. So the thing that we should do here is just substitute the given values to the x values and the y. Okay, this would be like this: 2 times negative 2 squared plus 3 squared plus negative 1 squared. Then the answer will be 2 times 4, the quantity of 4 plus 9 plus 1. Then the y value, so this will be 2 plus negative 3 plus 4. So it will be 2 minus 3, since positive times negative is negative. 2 minus 3 equals negative 1 plus 4. So the answer will be 3. So we will add this first. 2 plus the quantity of 13 plus 1 will be 14 plus 3. So 2 times 14 is 28 plus 3 is 31. So that is the final answer. Another example that we can face or encounter in sigma or summation notation. Example number 3. Let's say that the example is summation of 3x sub I squared plus 6 as I moves from 1 to 3. So it will be like this. So extract 3, then expand. Since the lower limit is 1 and the upper limit is 3, this will be the starting point. It would be x sub 1 squared plus x sub 2 squared plus x sub 3 squared. Then this is the constant. As mentioned in property number 2, constants should be multiplied in the upper limit. So 6 times 3 or 3 times 6. Like that. Next, as we have given the values x sub 1 equals negative 2, x sub 2 equals negative 1, and x sub 3 equals negative 4. So we will substitute it to the x. So the values will be substituted to 1 times negative 1 is 1, plus negative 4 times negative 4 is 16, plus 18. So first is we need to get the sum of this. 4 plus 1 plus 16 equals 21. Then multiply into the constant. 3 times 21 equals 63, plus 18 is 81. The final answer is 81. Next, let's proceed to the example number 4. Let's say that the example is the summation of 3 plus 5 y sub I squared. So, as I goes from 2 to 4. So, again, we need to extract the 3 first, which is the constant, and it can be multiplied to the upper limit. So, 4 times 3 is 12. Next, extract the constant, 5. So, the starting point is 2 and the end point is 4. So, it would be y sub 2 squared. You must be very careful in using the squared, because you may get wrong to your answer. 5 should be the quantity of y sub 2 squared plus y sub 3 squared plus y sub 4 squared. Be careful in using squared. So it would be 3 times 4, 12 plus 5. Then the values, there are given values, which is y sub 2 equals 3, y sub 3 is 4, y sub 4 equals negative 1. So since the given in y sub 2 is 3 squared plus the given value in y sub 3 is 4, so 4 squared 16. Then the given value in y sub 4 is negative 1, so negative 1 times negative 1 is positive 1. Next, 12 plus 5 times the quantity of 9 plus 16 plus 1. So get the sum of this. 9 plus 16 plus 1 is 26. Then copy 12 plus 5. 5 times 26 is 130. Then 12 plus 130 is 140. The answer is 140.
How can we use sigma notation in real life? Sigma notation can be used by getting the sum, especially for an accountant. Also, sigma notation can sum up numbers easily and takes a shorter time compared doing it one by one. It can be used to predict savings and know a certain sum.